So what I'm doing now is I'm going through and just checking the Riaa curve of this phono section. Now there's a lot of different methods to do this. I'm doing a very oversimplified way. It works, and that's all that matters to me. It at least gives us a baseline so we know if we change something in the stage that affects it, we'll know that it's something that we did and not just the way that the circuit works. And what I mean by that is, let's go back a little bit. For those of you who are not into phono or into vinyl, don't understand this. When a record is cut, in other words, when you make a record, it is not recorded linearly with the way, for instance, a tape or something else would be recorded. They put what's called a pre-emphasis on it. And what that means is they apply a certain curve of equalization to it, meaning they boost the upper frequencies and they cut the lower frequencies. And then when you play the record back into the stereo, there's a special circuit called your equalization circuit that reverses the process. So it boosts your bass back up to where it should be and reduces your treble down to where it should be. And the reason of this is the mechanical limitations of how a needle tracks in a record. So when the stylus is tracking in the groove of the record, if everything was linear the way that a normal recording would be done, the actual needle the stylus would have to travel way too far to reproduce the bass notes properly, and the treble notes would have a lot of distortion and noise in the background. So you would have a lot of distortion without an Riaa equalization applied. So basically it's just like adjusting the bass and treble and mid-range and everything before you cut the record, and then reversing the process when you're playing it back. So what we want to, and there is a internationally recognized curve called the Riaa curve, which is the amount of boost and cut at certain frequencies that you want to apply. So that can be looked up, and I just have a chart that I use, and I actually just went through and calculated because it's all done in decibels. And so I just took the decibels and just changed them into multipliers. And that's what this little chart is at some frequencies across the spectrum to give us at least an idea. And then what I do is I put in my signal generator, and I put a low signal somewhere around 2.5 to 10 millivolts. That's it. And I do enough to get, and I fine tune it until, on my scope anyway, I get a nice even number. So right now at 1 kilohertz, and if you notice at 1 kilohertz, that's our center frequency. That's the frequency with no multiplier, times 1. See that? So we start out at 1 kilohertz, and I adjust my millivolts, I fine tune it until out of my record jacks, so my record out jacks in the stereo, I plug my scope into there, and you can see I adjust it till I get 500 millivolts. Now why 500 millivolts? It's a random number I picked. It's low noise, and the input drive to the phono stage is roughly where we want to be, simulating a phono cartridge. Now here's the thing. Let's just pick another frequency like 250 hertz. So if I change the frequency to 250 hertz, it should be 2.18 times whatever it is now. So 2.18, and we'll do the math, 2.18 times 500 millivolts should equal 1.09 volts RMS. So let's go to 250 hertz and see if that's what happens. .09, look at that, dead on. And I'll show you another one. On the high frequencies, it should go down. So for instance, if I go to 5 kilohertz, it should be 0.93 times 500 millivolts, right? 0.393 times 500 millivolts should be about 200 millivolts, or 196, 197 millivolts. So let's go to 5 kilohertz. And what do we got? Right between 0.19 and 200 millivolts. See that? So somewhere between 190 and 200 millivolts. Dead on. Now I'll just skip ahead. I went through all of those frequencies, and the RIAA circuit in this is tracking absolutely perfectly. So that tells me I do not want to touch anything in there. Now the only thing I have noticed is there is a wee little bit of hum, but that just could be that the whole thing's open right now. I don't have anything closed up and grounded properly and connected properly. And remember, a phono stage is very sensitive. It's got a lot of amplification in it. So long story short, this phono stage is working perfectly, so probably all I'm going to do is just change the electrolytic capacitors out, and that's it. Nothing else. We're just going to leave well enough alone. And then we're going to go through and do this same test and make sure it's tracking the same way it was before we do anything to it. So that's just something to do. Now on on some of the lower end units, I don't bother going through all this, but this actually has a fairly nice phono stage. It is nowhere even remotely near what was in that Sansui AUX1. The AUX1 to me was a phono stage with an amplifier around it, and this is very much an amplifier with a phono stage and a tuner around it. That's kind of how I look at it. But the phono stage is excellent in this one. It will not handle a moving coil cartridge. For those of you who understand what that is, you have to use a matching transformer, but it will work fine if you put the matching transformer on it. No problems. So anyway, let's take it back apart, and we can start on the phono stage now that we know that it's tracking properly. And that's just a quick technique how you can check a phono stage. As long as you have a signal generator that has a small enough output that you can adjust. So I can adjust 1/10 of a millivolt. So 0.1 millivolt increments I can adjust with my Riaa DG4162. So if you have one that can do that, this is the way to go. So there you go. So I've begun the restoration of the equalizer amplifier, or the phono stage. And the first thing we're going to address is, if you look right here, they have 2 of those orange low noise capacitors back to back, and each one is 10 microfarads. Now why would you do something like that? Well, this particular part of the circuit requires a non-polarized capacitor. In other words, it's going to conduct in both directions, and of course an polarized electrolytic won't work. But if you put 2 electrolytics back to back, just like this, you tie the negatives together, it turns it into a bipolar or a non-polarized capacitor, with the trade-off that your capacitance is going to be 1/2 of what it was. So if you have 2 10 microfarads in series, you're going to end up having a 5 microfarad non-polar capacitor. So we're going to do something a little different. And if you look, here's the old ones. Here's a set of them here. And if we measure up what this is, and we connect here, I don't have it connected right. Hold on a second. There's some crud on these leads. There we go. And you can see you have about 4.8 microfarads. So it's not exactly going to be 5 microfarads. And what we're going to use is one of these really nice film capacitors. These are very high quality, and they are much lower noise, much nicer than an electrolytic. And if we measure it, it's a 4.7 microfarad. And you can see it's reading exactly the same. So we're going to use those in place of it, and that'll take care of it. And the only thing we're going to have to do is, hold on. So we just inserted the capacitor in one of the openings, and then the other one we're just going to put a jumper. And you can see on the back that completes the circuit between here to here. So it kind of bypasses that. So there you go. So that's what we're going to do there, and then we're going to go through. Again, we have these 2SA726s. We have a couple of them in there, and notice they're blue dot, so they're going to be in that same gain range as the other ones we replaced. And we're going to replace those as well and recap it, and it should be ready to go. And we'll do our test over again to make sure nothing has changed with our IAA settings. Moving right along, we got this one all done. All the caps are in. We replaced the two transistors. Everything's good to go. Everything else tests good, as we saw. I'm going to just finish cleaning things up a little bit, and this will be ready to go back together. And we're ready for the final inspection before the covers go back on. We'll just give it a quick once over here. Just kind of check it out. And I think this thing is ready to go. Nice. Alright, we're going to put the bottom cover on so we can check alignments and do some things like that. And get this thing set up on the bench for some final testing and then some alignment for the tuner and so forth. Well, the receiver is mostly put back together, and man did it turn out nice. And an interesting little story here. If you notice, here's the old corner pieces right here. And they're just plain old dark brown walnut. And kind of changed it up a little bit. I put these little rounded ones that I made, but this is an interesting story. This is actually called American sycamore, and sycamore trees grow kind of next to creeks and bodies of water, and they're a very interesting tree. And my father-in-law had one in his yard down by his creek. He has a nice big piece of property, and a huge branch fell off of it, and we cut it down and cut it into pieces, and I kind of cut it into small boards and had it sitting and drying in my shop for probably about 5 years. And when you cut it down, it makes this really beautiful lace pattern, you can see. And I thought that really looked nice. And I thought, you know what, that would be perfect to just add some trim to this. So I ended up doing that, and I am so glad I did. I mean, if you get up kind of close, you can see how you see that striping pattern there, medullary ray fleck they call that. But as opposed to kind of the plain brown walnut. But we're going to keep these in case somebody wants to put them back. But I think that color is going to match very well. I used that candlewood stain and got it to kind of match better to the case itself. Now the case needs worked on. But anyhow, we got the faceplate and the knobs all cleaned up. They turned out pretty well. And got all the lights fitted in. And yes, here is the upgrade that the previous owner did. They're working fine. So we're hooked back up to our signal generator, and we're checking our RIAA again. And we're back to 1 kilohertz, and we're still getting our 500 millivolts. And as I go through, go to 5 kilohertz, and it's back down to the 1.9 or the 190 millivolts where we wanted. 194 is what we needed. And if we go to our 250, you can see it's right around that 1.09 volts. And don't worry about that little wobbling there. There's a little bit of noise caused by a ground loop with my signal generator because I'm not using any kind of isolation or anything like that. So that's all that is. It's no problem. But I went through and checked all my numbers, and with our new recapped and rebuilt phono stage, it's tracking the equalization is perfect, and this thing is working flawlessly. So the next thing we're going to do is we're going to kind of do a little bit of a burn-in test on this thing and make sure it's good. We're going to finalize the bias and offset, make sure they're tracking properly, and then once that's all good, the only thing left to do on this receiver is do the alignment of the tuner. And the tuner's all been recapped. I did that at the same time that I did the phono stage. So really, I may only show a little tiny bit of the tuner alignment because I've done so many of them and I have so many videos posted of it. But there may be one or two interesting things I may want to show. But other than that, get this aligned, get the case finished up, and this thing will be ready to go. And finally, last but not least, by an overwhelming margin, you all said, including the owner of this, that you like these little caps best of all. So that's what it looks like with them. And let me give you a downward view. So I'm going to end this video right here because I really wanted to keep it pretty specific to the phono stage and that little how we test it and so forth. I did do a check out of this tuner and it is a mess. It's a lot more of a mess than I thought. So I'm going to have a few things I'm going to have to deal with. I don't know how much I'm going to put on camera because I still have some other tuners that need done in future videos. But I will put a couple highlights up. So anyway, I'm going to end this video right here and get it posted. I know I've been kind of putting them out a little more often lately because I've kind of been able to cobble the videos together and get them edited and out there. Things are probably going to get busy here for a while, and I'll go through some phases of having time and not having time. But I was glad I got this far here, and really appreciate all of your wonderful comments. You guys are awesome, and I appreciate it, and that's really the reason I do this, because I enjoy sharing it. Anyway, peace, joy, happiness, and good health in your lives. We'll see you again in the next part coming up here soon. And I wish you all well. Take care, and we'll see you soon. Bye-bye.